Hi guys, revisiting another one of my old projects because I've had some comments on it. This is, well, it's a fan boat, electric motor there, propeller, and on this servo I did have a rudder on the back to direct the thrust so we could turn the boat. But the purpose of the exercise is to have a look at the ESC that I'm using, which is this. It's actually the circuit board out of another servo. I don't know if you can see. Let's get a pointing stick. I think that's glued in there, so I can't pull it out and look at it. But you've got the circuit board there, and then there's two resistors up at the top there. They replace the potentiometer that's down in there, which is how the circuit knows how far the servo is actually turned. So there's three wires come up from the potentiometer. For some reason they happen to be two white ones and one red one there. And on this one, as I say, we've replaced that potentiometer with two resistors. Two balanced resistors or equal resistors, so the servo or the circuit always thinks that it's still pointing to the midpoint. Doesn't matter what you do on your transmitter, or in this case servo tester, the servo thinks it hasn't moved. So you can turn it one way and it will keep turning, the motor will keep turning, because it hasn't reached the point that the signal wire has told the receiver, I won't call that bit, control circuit, to stop at. So it just keeps going. So it's a common modification for people who want their servo to do a continuous 360-degree rotation. A lot of robotics use it, so they can use this as a geared motor to drive things continuously. I've done a few little cars with it. There's a couple of modifications you have to make to it, because there is actually a mechanical stop that stops it going too far, so you have to get rid of that mechanical stop. In this case it looks like it's that sort of half moon shape top gear there, and there's a peg inside there that you probably can't see, so that can't go more than, what's that, about 180 degrees. So you need to take that bit out. I won't put it out just yet. So that it can go the full 360. I've done some videos on how to do it, and there's plenty of other videos on YouTube on it. So getting back to where we were, the comments that I had were, why have I used, I think there are 2.2k resistors in there. Red, red, black. I think they are. 2, yeah, red, red, black. And the reason I use them was that's what everybody else uses. But we then get into the discussion of what happens if you use different resistors. Oh. Let's unplug that, otherwise it'll keep going. Now my opinion is, as long as they're matched, then you can use the servo as an ESC, and you've got forwards and backwards. If you make them completely unmatched, I would think you could use them as an ESC for a model aeroplane. So you've got full range, you've got 0 all the way to full range with no midpoint, I think. So I thought it might be worth having a try at that, because I've had to take this one apart anyway, because I thought it might be faulty. I don't think it is, but I can't see anything wrong with it. But I thought, while I've got it apart, we might do that. So I've got a breadboard here somewhere. I'll wire it up to the breadboard. and then we'll try different resistors on it and see what effect we have. So I'll desolder this, put some wires on it to extend it onto the breadboard, and then we can put different resistors on there and play around with it. Before I desolder it, I will just demonstrate it working. That's just occurred to me. So, right. I think you can probably see that working. And it also occurred to me that I might be able to do this easier than I thought without the breadboard. Because if I take those gears out, because they're the ones that turn this gear, that gear is the one that would normally have the arm on it, the servo arm, which somehow or other has dropped off and I've lost. Oh, there it is. So that would normally sit on there. And while I was playing with it, that happened, that came loose. So you may be able to see the motor is still spinning. Might have to zoom in a bit more. Right, this is what we're looking at just here. That is spinning. I'm trying to get the 0 point where it should stop. Yeah. Right, that's the midpoint where it should stop. And it drives continuously because we haven't got it linked up to this bit, which would come to the hard stop on the inside of there. So that's running. I'm trying to find the midpoint. Right, that's the midpoint at the moment. If I turn the gear, or the arm, the midpoint, which is the balance point on the potentiometer, because I'm changing where the midpoint is, the balance point, by moving the potentiometer. Probably here, I hope. I'm actually controlling the servo in reverse. By altering the potentiometer position, I'm making the motor go faster or slower, or change direction. Because the feedback into the little circuit board is telling it it's not at the required position, so it's driving to try and get to the required position. So if I press that button there, right, according to the servo controller, that should be in its mid position. So I'd need to move this . Alright, so that's the mid position. If I press auto, oh, wrong button. What it's doing now is driving all the way one way and then driving all the way the other way. But that's not using the feedback at all. That's the circuitry in there just giving it a full blast one way and then a full blast the other way. If I press that again, that's back to manual position. So I should be able to find the stop point. Right, that's the midpoint. Looks like it drifts a little bit because I haven't touched it and it started moving again. So back to what I was talking about and changing the resistance values. If I push this all the way one way, then servo is spinning. I can't actually get it to stop though. Yeah, if I turn it all the way there, it's not quite stopping. Let's bring it back a touch. I'm trouble getting it just right. But somewhere there is the new midpoint that's all the way at one end. So if I go the other way, yeah, I think I will have to use resistors because you can't actually see what I'm talking about. It stopped because I've got this all the way at one end and my servo tester is all the way at one end. I turn it all the way the other way, it's driving. Turn this all the way the other way and it should stop. Yeah, it's not going to stop quite there. I've got to come back a little bit. Right, stop position, and we're all the way around there now. So if I were to use this as the throttle on an aeroplane, we could either fix the potentiometer all the way around on its range, or choose some resistor values. Now if I disconnect this and try and measure what we've currently got on that potentiometer, I'm afraid my wife's making a lot of noise in the other room now. Not much I can do about that. Alright, potentiometer. .1. Let's go up to 20 just to. So that's 1.1k fully wound one way at the other end. 3.1k the other way. So according to me, if I put resistors on there, well, the best I'm going to do is 1k and 3k, isn't it? I doubt whether I've got a 1.1k. Well, we could play about with trimming potentiometers on here as well. I'm waffling a bit, sorry about that, I'm thinking as we're going along. But it looks to me like 1k and 3k should give us full throw for a one-way throttle with no reverse. What have we got? We have got a bit of a mess. 10k, 4.47k, 2.2. 100k, 680, these are in a bit of a mess. 1K. Yeah, 1K, but there's none attached to it. That means they're loose in there, doesn't it? Oh, that's annoying. Meg. What's that little trim? It's 10K, isn't it? Might be able to use that. Think about that. Right, gonna have to measure some of these. Right, got a bit overcomplicated, and I've still got the problem of finding the neutral position. Okay, what we've done here is we've taken the servo apart. That's the potentiometer out of the servo. That's the... oh no, we're not even in shot. Oh, let's move this a bit. Okay, that's the control board out of the servo. So we've got potentiometer, servo control board, and we're running that little coreless motor. And I can either, let's switch this off and on again a sec. Right, if I switch it on, okay, normal servo control, midpoint, and we can go backwards as it is, or forwards. And we do have proportional control, but it's a very fine adjustment. So we've got slow. I hardly need to touch it. That's full rate. I can still turn back quite a bit more and it makes no difference. Right, that's the midpoint. You see it drifts a little bit. And I'm not quite sure why, but it does. So getting a 0 point is a bit difficult. If I turn the potentiometer, if we note at the moment that's our midpoint there. If I turn it all the way one way, right, I can't quite get it to stop. I have to twiddle with the potentiometer to find the 0 point, but we're now all the way here. Move it again. So we've got the full range, but actually, even though we've got the full range of movement, the motor's at full bore right from about there. But it doesn't settle on 0. That's going backwards a little bit there. Right, so that's with the servo's original potentiometer. Switch that off, go back more or less to the mid position. If I shift these wires along to here, what we've got there is 1K resistors. So we've got 2K one side and 2K the other. Power on again. Right, that's our midpoint. Okay, off again. Let's just try that with 1K instead of 2K. So we're just using those middle two resistors. So it's 1K either side. So it looks like we have exactly the same amount of control. Off again. And we'll just try unbalancing it. And I'll have 3 on one side and 1K on the other. So our midpoint's over here somewhere now. Doesn't seem to make much difference to the amount of throw that I have. It just moves the midpoint one way or the other. And the only other thing I can try, I've got a 103, is that 10K? Yeah, 10K variable potentiometer there. That I've been playing around with already, so I can't remember what position I left it in. Okay, I've left it all the way one way. So over here we're really not making any difference. We haven't got a 0 point there, so we'll have to twiddle that a little bit. Alright, so that's our 0 point. So it does drift. Yeah, there we go. So if I put that, right, that should be in the middle position. But getting that 0 point in the middle. even when I get it, if I leave it for a while, yeah, it drifts again. So not a perfect setup. Oh, that's interesting. I seem to have turned it right down. Ah, silly me. I'm misleading you here. I press that button, which has locked it into the midpoint. Me twisting that makes no difference. So that's midpoint. Press that again, it'll go into wiper mode. Now we're in manual mode. So in fact, even though this has been an incredibly long video, I think I've covered off the point that I was actually asked about what resistance I should be using there. I use 2.2k because that's what other people had used before me, and I watched their videos before I did mine. Changing it to just 1k either side didn't seem to make any difference. We still had the same amount of control. Using the existing potentiometer, which you could do, you don't need to have those, as long as you can put a bit of glue over that or something to hold it in place so it doesn't accidentally move, then you could just set that to its midpoint, glue it in place, and you don't need to buy any resistors. Or I've got a variable potentiometer there, a potentiometer there, which is a 10k one, so that's 10 of them, and midpoint would be 5k either side, and it made no difference, it still worked exactly the same. So I think I've covered all the points. I've no doubt somebody will say, ah yes, but what if? And if they do that, I'll do my best to answer it. But it doesn't seem to make any difference what resistors you use. As long as they balance, then the servo board thinks it's in the middle position. And when you turn it one way, it gets the message that tells it to drive till it gets to the balance point. But because it'll never reach that balance point, well, because it's already at that balance point, it just keeps driving. Whereas on a normal servo, it would stop. Normal servo, in there, on. It turns until it meets the point that the potentiometer is telling it it's got to the right place. Unfortunately, I think I've explained that well enough for me, but I've probably rambled so much that I've probably lost the thread for a lot of people. Apologies for that. Ask me a question about it and I'll do my best to answer it. I thought I'd finish this, but then I had some other thoughts, and realised that what I'd demonstrated, I'd gone up in resistance value, but I hadn't tried going down in resistance value. So if I just disconnect this all, what we've got here is two 10 ohm resistors, not K, just 10 ohm. So we've got two 10 ohm resistors to fix our midpoint. I do get some heat here, but I get the same amount of heat. Makes no difference which resistors I use. So if I run it hard, this does get too hot to hold. So that's gone right down to just 10 ohms each way. How about if we just short it out? So we got no resistors in circuit. Back in again. I don't know if that's a good idea or not, because I don't know enough about this circuitry, but it certainly works. So just shorting straight across those three terminals, doing away with any resistance whatsoever, and it works. So as far as I can tell, all this fuss about different resistors and values may be completely irrelevant. Still get the same thing where you think you found the 0 point, and then a little bit later it seems to kick in and start wandering. Now, whether that's a problem with my servo tester or the board, but it does, well, it's not going to do it now, is it? That's typical. That's a little bit warm, but I've been playing with it quite a bit. Well, it looks like I've actually found a central point at the moment. Yeah. So there. Played around with different resistances, and I've ended up using no resistances whatsoever. That's all three wires just shorted together. So I'm going to have to go and re-edit the video that I've just compiled and add this on the end. Hey, thanks for watching. There's plenty of videos on my main channel with more added daily, so don't forget to subscribe and enable the notifications to keep you up to date with my new releases. You can help keep my channel running by donating $1 on Patreon to buy me coffee. You can always find more information in the video description. Thanks again for watching.